Okay. Hi, everyone. Good morning. First of all, thank you for joining in on Saturday morning. I know it might be a little too early for a lot of you. Tamil Nadu is very happy to host this virtual hands-on session on Data Prep Kit, which is an open source project. And since a lot of you have been asking us to conduct virtual sessions, and especially on open source, we thought it would be a good venue to have people from IBM Research to do this session. First, I would like to introduce both the speakers for the day. So we have Hima Patel, who's a seasoned AI practitioner with hands-on experience in developing algorithms using ML, computer vision, and NLP techniques in several domains like healthcare, oil and gas, and enterprise AI domains. She is currently working as a senior research manager at IBM Research. She has also been associated with the organizing committee for Grace Hopper's Conference India, and she has been a co-chair for AIML track, Tech, Tech Expo track, and she has also helped charting a new program called Tech Pathways for GHCI and Anita Borg India. She is a member of Executive Committee of IEEE Computer Society Bangalore chapter and founding member of Data Science Exchange Platform and Data Conversations Platform. We are very happy to have you, Hima. And along with Hima, we also have Shivdeep Singh, who's a versatile software developer and engineer with a passion for building sophisticated, scalable systems across diverse domains. He has worked for top companies for almost 12 plus years and is currently a research software engineer at IBM Research India. His expertise spans across AI NLP, where he has tackled large scale data pipelines, built LLMs, fine tuned LLMs for critical projects, and even crafted end to end chatbots with advanced audio and avatar capabilities. He's adapted different technologies like distributed computing, IoT, edge computing, multimedia video software, and embedded system software. Thank you, Shivdeep, for joining. And I would like to, now let you both take over, and we'll look at a open source project today, and they'll be walking you through the entire library, as well as they'll demonstrate a hands-on example on how to contribute and how you can also use the library for prepping data for LLMs. Yeah, over to you, Hima. Thank you so much for joining.
Thank you so much, Abhinaya and the whole team of AI Tamil Nadu for inviting us to this session. It is our pleasure to talk to this group here. Um, I'll start with a little bit of what I and Shivdeep do and what is our goal. We have been doing data preparation for large language models for quite some time. That's our day in day out job, and we have been behind all the data preparation for the Granite code models that have been recently open sourced by IBM. So that really is our area of passion. And since we are doing a lot of work in house, we thought that this is a good area for us to actually open source and work with the community, because it's such a vast space that that it provides, I think, a, a rich opportunity to for diverse ideas to come in, for diverse people to join in, people who are working on different use cases. So that's what we're going to talk about here. I lead a team at IBM Research. I'm also a senior technical staff member. So I'm responsible for all the code data preparation globally at IBM Research. And Shivdeep, my colleague, has is all hands on, right? He's our lead on to this open source data project, and he's very well versed with how to deal with data at terabytes and how to process and all of that. And we'll be sharing some of that as we talk through in the session today. So this is how we intend to spend time today. We will start with an introduction to data prep for LLMs. What does it mean? What are some functionalities needed for data prep for LLMs? Talk about some of our experiences there. From there, we will go to talk about overview of the Data Prep Kit. So Data Prep Kit is our open source project, which has all these code available for doing data preparation for LLMs, and is useful for both pre-training, fine-tuning kind of scenarios. Shivdeep will then take us through a hands-on demo to say that, hey, if I'm a user and I'm, let's say, trying to fine-tune a model or instruct tune a model to do something, then how can I get started from the point where I have my data and use the data prep kit easily to process my data, right? And then he will also talk about that, hey, for my use case, I realized that I need to do some additional processing of my data. So how can I very quickly build my own data prep kit operator and also contribute to the open source community. And then finally, we'll be talking about some discussion on how this community can collaborate and help grow this area of data prep kit for LLM. Okay. So with that, let me get started. I'll just start a little bit with an introduction to IBM research. If you've not heard about us, we are part of this company called IBM. We are part of the research division. Globally, we have about 3,000 researchers with offices across the globe. And IBM Research has a very strong history of innovation, as you can see across the various awards given to different researchers at different locations across IBM Research. We are part of our India office. So we have two offices in India. One is in Bangalore and other is in Gurgaon. And again, I think, a lot of very interesting work happening here across hybrid cloud, AI, quantum. Uh, it spans, large gamut of research areas. Okay. With that, let's, I think, double click and go down to our topic of the day. So let's start with, introduction to code LLMs. Um, if you have not seen this, right, maybe this GIF will give you a good idea of what the code LLMs do. This is a So the whole idea of code LLMs has been to say, hey, if I'm a developer, can I get assistance from an AI model to help me generate code, which is one of the most popular use cases. And we'll talk about other use cases where LLMs can come handy. And for example, in this scenario, you can see this is a small video from one of the IBM products that is called as Watson Xcode Assistant, where you can see that as a developer, you are trying to write a code and you ask and trying to write this method and you ask the LLM to make a suggestion. The LLM would make a suggestion. One can look at it and say, okay, yeah, this looks good. I'm just going to insert it, right? So this is how the world is changing. This is how this is going to be, I think, the new era of software development, where the software engineer is still going to be very much needed, very much in charge, but now is going to have tools to help accelerate their work, right? And this is one of the many products available in the market. There are, of course, products from different companies that help a user um, uh, get better or accelerate in their software development tasks, right? And this has been an interesting journey. And every time, I give a talk, I feel like, okay, this chart, is now outdated. That just tells us that this whole community has been growing so fast. And as you can see in the last couple of years, when some of these were some of the early models were really, I think, in a research lab space, wherein, hey, it looked like a nice proof of concept, and it looked like, hey, this actually looks cool. If we can get it working, this will help a lot of people, right? I think we were in that phase, and in the last 2 3 years, you can see the growth that the whole community has come together, and there have been so many models. And like I said, every time I give a talk, I feel like this chart has gotten outdated, which is true, because now I think there's some other models here. Like, for example, our Granite models are not here. The DeepSeek coder has a DeepSeek coder V2 model. I think there's a code Gamma models from Google and so on. But I think that's the whole point, that this is such an active research community, and now it's at a place where it's not in research labs, it's not, okay, fancy demos and cool POCs. This is out now in the real, and something for all of us to take advantage of. So given that, let's think about what are some code LLM popular use cases. We of course spoke about the code generation use case, wherein, if you remember in the video that I was showing 2 slides ago, we said, hey, I'm, as a developer, I'm writing code, and my code LLM assistant can help me generate code, right? Okay, so maybe let's go 2 slides down. Just a quick recap. And apologies, folks, for this technical challenge. Yeah. So I think I'll just do a quick recap, just so that people can be on the same page. Yeah, I think we can stick to this slide for a second. This is a little bit of intro about us at IBM Research, what we do, where we're coming from. And Shiv, if you want to go like 2 slides down. Right. I think this is the picture that I wanted to show as an intro to code LLMs. As you can see, this is in Visual Studio. There's a developer who's writing code and is asking the assistant to say, hey, can you generate the method? And the assistant generates a method, a user can look at it and insert it into the code, right? So that's how the code LLMs have been helping software developers, accelerate in their work. We can go to the next slide. Um, Right. I think this is a chart that I was showing, where I was making a point that this whole, the code LLMs as a community has progressed very, very fast, and to the point that it's not just nice, happy demo or a cool POC. This is out in the real, right? And again, like I said, since this space is evolving so fast, it is just hard to, I think, keep this chart up to date. There, I think, some latest models that have come in the last 2 3 months that we've missed out here. But I think that just tells that the pace at which this field is developing and growing, right? We go to the next slide. We were at the point where we were discussing about the code LLM popular use cases. So the example video, we saw the example video on code generation. which said, "Hey, I'm a software developer. I'm writing my code. Can the LLM help generate some new code and thereby help me accelerate my work?" But I also wanted to chat about what are some other popular use cases that people have been working on, right? So broadly, you can categorize the code LLM problems into three big buckets. One is natural language to code, other is code to natural language, and third is code to code. So natural language to code basically could mean that as a user, I am giving my intent in natural language. For example, I'm saying that, hey, write a code to generate the Fibonacci series. And the LLM would then go ahead and generate code for it, right? So that's an example of code generation. Um, another popular use case is on the unit test generation, where unit test generation basically, I think, uh, I think, also lies in the bucket of code to code, wherein the input could be to say, okay, given a certain code, write unit tests for it, or it could be a user could specify the intent and say, write unit tests that covers certain parameters and so on. Then I think there are use cases around code retrieval to say, hey, given a certain intent, can you retrieve the right code snippet or the code snippet that is closest to the current code snippet or closest to the intent that the user cares about. The other category of use cases is then code to natural language, where you say, hey, given my code, can you now summarize this code for me and tell me what is this code doing, right? So, for example, and this problem has various levels of complexities. So a starting point could be where I could, as a user, say, here is my code to, let's say, generate Fibonacci series. Okay, so if I give this code to the LLM, I wanted to tell me back that this code will, generate Fibonacci series, take in the following input, and here is the logic of what it is doing to generate Fibonacci series. So that is code summarization at a code snippet level. Or let's say at a method or a function level. Then you can do code summarization at a whole application level, where you say, hey, here is my application, and this has this certain classes, it has a certain methods. Can you summarize and tell me what really is going on here, right? Which is, I think, a whole new space, and very important, especially for use cases where a software developer is, let's say, trying to do software maintenance, or even more important, when you think about legacy software systems which are built on languages that where I think the skills are not, you don't have so many skills now, so you could use a code LLM to help you summarize and say, okay, here's this new code base. Okay, help me understand what's really going on, what is the logic, how do I quickly get accelerated with this, and so on, right? Another type of use case where people use is to say, okay, automation, when I'm doing my work, right? So I've written a code, I want to commit it. Can the code LLM, look at my code and generate useful commits and PR messages Thereby, in a long term haul, my software development maintenance will be a lot more better. Right. So that was the second use case, second category of use cases. The third category of use cases is code to code, where you say, hey, given a code, can you please fix the bug in this code, right? Which is also called as code fixing, right? So I have certain code and I know there is some bug. Okay. And again, this can also go to levels of complexities where you say, okay, here's this small function, please help fix a bug. The whole problem becomes way more complicated when you say, hey, instead of this function, I have this application, this is the bug that I'm seeing, and this could be related to across, two three different classes, two three different functions. Changes have to be made in different places, and make sure that, hey, if you're making a change, you're not actually breaking something else, right? The typical kind of things that we know about. And in that scenario, I think the problem becomes whole lot more complex and interesting, and also useful, where I think where I still, I think, believe that the software engineer is still in the hot seat, but using all these tools, they can, do their work faster, accelerate, etc. Code translation is again another very interesting use case, wherein you want to start thinking about, let's say, legacy systems which are written in, let's say, Fox Pro, COBOL, right? And you want to modernize these softwares to, latest languages. Then now think of this, right? These are softwares that are running, let's say, in banks or, institutions. The business logic is all set, right? It's a real time production system. So taking a big set of software like that and saying, hey, this is all COBOL code, I want to just, convert it into Java, is a particularly hard problem, even for humans, because it's going to, I think, take expertise where someone needs to understand the COBOL code, where make sure that all the business logic gets converted in the right way, and so on, right? So it's generally, I think, is a hard problem, and thereby, help from code LLM assistants could be useful to, let's say, summarize the code, right? So explain what the business logic is, then help do some translations and so on, right? Another category is to do code search, where you can say, okay, I have a huge repo, right? And here is this code. Can you write search, I think, other codes that are connected to it, and so on. So I think there is this whole gamut of use cases that code LLMs can support, and that code LLMs can, how they can make the life of software engineers much better, and help them accelerate, do their job faster, right? So now, I think, now that we've, I think, looked at what code LLMs are, what are some popular use cases, we will start diving into the topic of interest today, or to start thinking about, hey, how do you even build this code LLMs? And we'll focus largely on, right, the data prep part of building LLMs, right? So if we go to the next slide, please. Okay, so this is the code LLM development lifecycle. You can see, I think, let's read this chart from bottom to top, right? The bottommost layer is to say, okay, everything starts with data. So I'm going to get like this whole terabytes and terabytes of data. Lots of work around data processing and engineering, which basically says start from code repositories, right? So that's my raw data. And you want to process this data, clean this data, and make it ready to the point that you tokenize the data, you get code tokens. Now this code tokens goes to the next layer of model building. And model building, right? Model building is basically going to take in the code tokens and use all these latest architectures to basically learn how to build a code LLM that can support all the use cases that we've been talking about. During the model building phases, right, there are a couple of, I think, couple of phases, right? The pre-training is the phase where we say, hey, I'm going to take the model from scratch and, bring it to a level. Pre-training, if you've been following the latest literature, is usually also now done in phase one, phase two. So it has its own variety of phases. Then comes another very popular thing. The next thing to do is to say, okay, now I'm going to do alignment of the model, right? So instruction tuning or model alignment are again very popular techniques wherein people pre-train the model, then they instruct tune the model, and it has been found that on instruct tuning the model, will do much better, right? So the first two steps are to say, hey, okay, I didn't have anything, I did the data, I built the model, so now, and I have instructed in the model. So now I have a model, a base model, right? Now let's, I think, start putting on the hat of a user who's trying to develop, you know, who's trying to develop or who's trying to develop a certain use case. Remember the various use cases that we spoke about, and is trying to use a code LLM to do that. So in from that, from a use case, if I am a use case person, what I would then do is to say, okay, let me take a model, let me evaluate how good these models are with respect to accuracy, speed, security, actual execution, right? If I take in the code that is generated by the models, does it even execute, or does is it just good looking code, and so on, right? And based on where what the use case is, there might be some use cases where the model that has been trained so far might just do a good job out of the box. But there could be a lot of use cases wherein you may want to do more for a variety of reasons. For example, let's say if I'm trying to do something like I want to do, I want to use my base model. I want to use a model to do code generation for, say, a language like Foxpro. And Foxpro is a language wherein you wouldn't find a lot of data in the open. But thereby, I think your model has not seen enough Foxpro data. So it's naturally not going to be that great at doing Foxpro code generation as it would be for Python code generation. So then this becomes a whole use case around, okay, model customization, where I as a user want to come in and say, okay, I want to, here is my use case, and I want to make sure that I take a model and I make it tuned for my use case. And popular techniques there could be fine tuning, RAG, etc. Right. So these are, I think, the interesting patterns of work that people do, right? And again, I think, needless to say, all of this, right, needs, all of these pillars basically needs scalable processing. We're really talking of data in the orders of terabytes, right? So at least the first two steps definitely needs large number of CPUs and GPUs, and fine tuning based on how much your data is, right, might have much lower compute requirements but will still need like some GPU requirements, right? So given that now we've spoken about the stack, right, of how one can think about the LLM development life cycle, we'll now zoom into the first the most box around data processing. And as we talk about it, we'll talk about one way I think to view our next few minutes would be to say, let's say, look at data processing that is required for the bottommost box that we are talking about, which is where we had no model and we said, okay, let's take the data and okay, build a model. Sure. So that's one place where data processing helps. The other place where data processing helps is on our topmost box, where we say, hey, I want to make sure that this model works for Fox Pro. I have all this Fox Pro data, and the model has not seen this data. So again, I need to process the data so that in a reasonable way, so that I can add it to the model and thereby make the model better for my use case, right? So we'll be talking about both of these scenarios as we talk through the data processing techniques. Okay, so if we could go to the next slide, please. Thank you. So this is one view of it, to say, hey, this is the view corresponding to what we had our bottommost box on data processing. We say, hey, let's take the input data. This is typically terabytes of raw code data that has been gathered by crawling, the open source repos like GitHub, GitLab, etc. So you'd like basically get like a lot of data. Then comes, I think, the intermediate steps of, hey, so we've acquired a lot of data, we want to prepare this data, we want to do the quality evaluation, and it's sort of like is a circular thing. So this is the work of this is what we will call as code data preparation pipeline, and this is a pipeline that works at scale. And once this data is ready, then this data can be used for pre-training, which is basically corresponding to our first block in the previous chart, where we're saying that, okay, I don't have a model, I'm just going to take all the data from scratch and build a models, right? So that's this one use case, right? And as we go to the next slide, I'm going to talk about really zoom into and say, how do we actually, what are some components that we use to do data preparation, and all of these. And now I think the way to think about this is that the components that I'll talk about are useful for both the use case depicted by this chart, which is to say no model, take the data, process it, and give it to the model so that we can start building a model. But also to the point where I say, hey, I have a model. Now I have my own custom data or Foxpro data, or whatever I want my use case to do better on, and take that data, right? And how do I now prepare that data so that I can show it to the model, right? So the next chart will talk about data processing techniques, which will focus on both the use cases. So if you go to the next chart, we can see that this is what a data preparation pipeline looks like. You can refer to our paper. It's in the same link, which gives a lot more details about this. Um, as you can see, um, the starting point is say, hey, here's the raw data, which is basically, let's say, if I was looking at GitHub data and I went and downloaded GitHub data, I would basically get like .zip file. So every repo gets packed as a .zip file. Now think that I went and crawled, let's say, all my FoxPro repositories. Right? Say I had 4,000, 5,000 repos, so now I'll get like 4,000, 5,000 zip files. Then we made an opinionated choice to use the Parquet files as our method of processing. So we take the raw repositories, convert them into a Parquet format, and in such a way that every row of the Parquet file um, holds one code file. So think about a repository that has 100 files. In that scenario, what happens is that file 1 becomes row 1, file 2 becomes row 2, and so on. So that's how the Parquet file is organized. Once we do that, what we want to do next is to follow or apply an operator that is called as exact deduplication. The goal here is the name, as the name says, the goal is to find code files that are exact duplicates of each other. And this happens a lot because, especially in code, wherein usually there is a base repository, and there's like someone might have forked a repository, and maybe that repository had 50 files, but this person made change only to one of the files, or just some configuration changes. So when you basically get both these repositories, all the other 99 files are going to be the same, but there's this only one file that has some change. So there is value to, I think, remove the exact duplicate contents, because and the whole idea is that you don't want to bias the model towards a certain set of data points, thereby exact deduplication is required. Next, what we want to do is to like I said, right, then all of this, if you're really building this kind of pipelines at scale, then for efficient and scalable processing, you want to resize all your Parquet files. All the repos could be of different sizes. So you want to basically put the repos into the Parquet files in such a way so that each Parquet file more or less has has roughly the same size. And the whole idea is that the same size enables you to use your cluster. So if you're using, let's say, Ray for your processing, and you're going to have different actors do the job for you, then having the same size roughly, it enables, I think, the most scalable, most efficient way to process data at scale. Right. The next thing that we do is to do programming language detection and filtering. Right. So now let's go back to our FoxPro use case and say, hey, for my use case, I basically want all the files that are related to FoxPro. I do care about, let's say, the README files, which usually come in the Markdown format. I'm also maybe okay to have maybe some text files that come along, but I don't want any HTML files, or I don't want any Python code that's coming in, because I really want to show FoxPro. So that's a choice that a user makes, and says that, okay, for my use case, this is what I want to do. Okay, great. Fine. So then we have a filter which allows a user to specify and say, here are the languages that I care about. And can you quickly just, find out the languages, find out all the code files that belong to these languages, and help, filter out these languages. Okay, so that's one. The next steps are right. The all the steps that you see are different steps of the data processing pipeline. PII detection, right, is to make sure that a lot of PII can be found in code files. For example, there could be names of authors, there could be names of organizations. So PII basically stands for personally um, identifiable information, and you want to remove all of these so that before you show to the model, for obvious reasons, right? So PII detection and PII reduction are important steps to be done. The next thing is that, okay, license filtering. Remember, right? If I've taken my data from open source, I want to make sure that I am using data only of license types that that I'm that an author has said that is okay to use, right? So for example, like Apache 2.0 is a friendly license, and if I have a repository and I say Apache 2.0, that means that you know I'm okay with the community using this data, but there could be more restrictive license types, right? So you want to make sure that we follow the wishes of the person who has put up the repo in the public and use only data or from license files that can be used, right? Then we have a whole bunch of techniques around what we like to call as HAP. HAP basically stands for detection of hate, abuse, and profane words, right? And you'd be surprised at how much that to of where all did we find HAP contents, but we do find HAP contents in code files. So again, we want to, I think, get rid of these kind of things, because for obvious reasons you don't want to show data that contains hate, abuse words, or profane words to the model, because the model basically learns the data that you're showing it. Then we have a bunch of code quality filters, where here we are getting very opinionated about filtering or removing code that could be bad code, badly written code, or data that is there in the code files but may not be code. For example, sometimes let's say an image has been initialized, or let's say model weights have been put in the code, which is basically a bunch of binary data or number or alphanumerical data, which is not that useful, right? So the code quality filters, this is a vast topic by itself, but the whole idea is that you want to do a quality control to make sure that all the data that you are showing to the model is actually code data, so that the model sees the best data and thereby learns from it. Okay. Uh, then we have things around fuzzy dedupe and malware scanning, right? So dedupe, we had spoken about exact dedupe. We said, okay, files look exactly the same. Okay, let's get rid of them. Fuzzy dedupe, we are saying, hey, file looks identical. There could be some differences, but they more or less look the same. Okay, let's also get rid of them for exactly the same reason why we want to do a dedupe, right? And then I think the last filter around here is around malware scanning, to say, hey, if my code files have any viruses, malwares, I just want to get rid of them. And then we do a filtering across all the filters, and then the data can be tokenized, and the tokenized data can then be put into the model. Okay, so I see there's a question. Do you want to, I think, Reese, maybe you can, I think, stop here, take some questions.
Yeah, hi Hima. So I have question in this code quality filters. Is it something like a static analysis on how good, like for example, because we have for different languages, like for Java, there will be different code quality analysis, and for Python, different things will be there. Is it a kind of an integration with a static analysis tool, or some other different techniques that will be included in this?
Yeah, that's a great question. Fantastic question. Um, Static analysis is definitely one of the dimensions of how we can do code quality. And you're spot on that this is every language will have a different way of doing it, right, and so on. So Soumya, once we I think go a little bit later and we start talking about data prep kit, these are actually the open areas where user where the community can come and contribute and say, hey, let me add a static analyzer tool for Java and for JavaScript and so on. So we'll chat a bit more about it towards I think the end of the session. But yes, you are spot on. Static analyzers are a type of code quality filter and actually very useful also.
Okay, yeah, sure.
Okay. Any more questions at this point, or should we carry on? Okay, maybe let's carry on. Feel free to, I think, interrupt and ask questions. Okay, let's. If we go to the next, can we go to the next slide, please? All right. Okay. So now I think what we've seen so far, we've looked at, I think, use cases. We've seen the theoretical diagram of what data preparation pipeline looks like. Um, we the next thing I wanted to do is to give an overview of the data prep kit and map to the discussions that we had so far on where you can actually find code to do some of these functions or operators that we just discussed. um, I'm going to, I think, I'm feeling a bit optimistic, so I'm going to try sharing my screen again and see if it works. Otherwise, Shivdeep, I'm going to request you again to share your screen. Okay. Can you guys see the screen?
It's moving here.
Yeah.
It's
Okay, moving also, right? Okay, super. Thank you. Okay, so this is the data prep kit. Pretty easy, I think, to find it. If you just say data prep kit in Google, you should, I think, come to this link. Um, the way to look at this open source tool is like this, right? So again, I think our goal here is that a lot of times we have LLMs, but and we were discussing of this use case of this making the LLM better for Fox Pro. That could be my use case, and Soumya's use case could be I want to make the LLM better for a different language, right? Let's say something like COBOL, or and Abhinay's use case could be I want to make the LLM better for a third language, right? Let's say SQL, right? Now, for all of these, and exactly to a point that Samya brought up, each of these languages will have certain differences, right? So and thereby the data processing and we can talk because I think we spoke about this point, we can talk about code quality as an example, right? That if I want to make sure that the code that I'm showing to the model compiles and there are no syntactic errors and so on. So for each of these languages, the technique that I use to make sure that I can compile the code is going to be different. Right. Now, what does this mean? Uh, what does this mean? This means that the space of building this LLM apps, right, for everyone's own use case is such a wide and it's such a long tail space that that I think that there's not going to be one whole, like there's not going to be one repo, there's not going to be any single person that is going to have all the functions. And then, what would happen is that in silos, everyone will go and develop their own work, and there'll be like a lot of just a lot of rework. And that is, I think, one of the other reasons why we decided to open source this toolkit. And what we have tried to do is not to say, okay, we are going to provide all the functions. What we've tried to do is we've tried to put like an opinionated way of what a data prep kit should look like, what its framework should be, what the architecture should be, and build it in such a way that if you are a user, you want to come and use this, you should be able to use it very easily. And if you are a contributor, and if you are, like, let's say, building a code quality check for your use case, then you should be able to contribute it back, and thereby your contribution could be used by someone else, and thereby you could also come back to data prep kit and get some ready-made functions which are contributed by others, and thereby just, I think, helps the whole community together, right? So to look at data prep kit, right, there are, I think, two three important things. You can see that I think we support different frameworks, so that you can find Python only code, you can find Ray, you can find Spark, and you can find kubeflow pipelines on Ray. And of course, these are at different degrees of development. And also, I think, will this also tells us, I mean, this is really, I think, for the open source community to come and pick and say, hey, I have a lot of Spark use cases, so someone will come and help with more Spark modules and so on. So and again, I think this is not a limited list. This can expand to more runtimes and use cases as required, right? These are the functionalities that you see that we just discussed in the slide 5 minutes ago. And I'll show you, where to look at this code and how to get to this code. What is at the core of it is our framework, which is called as a data processing library, which is all the code right here, which basically is a way for someone to quickly come and bring in their own functions, right? And Shivdeep will soon, in a few minutes, show us all how to do that in an easy way, right? And so if you want to get started, it's pretty easy. I'll take a particular function to just show how it works, right? So before you go there, right, if you want to look at what are the way this repo is organized, right, there are two important things. This is a data processing lib, which is the core framework, and then this is the transform folder, wherein the different functionalities are there. So if I click on transforms, I'd see, okay, there are some functionalities under code, some under natural language, some universal, which are useful for both code and language, right? Let's go to code, and we can see, okay, these are the functionalities that we were just talking about: code quality, malware, programming language selection, etc. uh, can click on one just to give a quick view. Let's say if I want to use the Ray version, right, to actually get it running and using, one probably just needs to do, like, two three different commands given where their data is, and they can quickly use this function, right? So that's where all the transforms are. If you go to universal, you will see things like exact dedupe, fuzzy dedupe, profiler, a bunch of things, tokenization, and so on. Right. And Okay, and there are also, um, if you are a first-time user, then there are a lot of different ways of how you can get started with it. But one really easy way is via using the example pipeline, which has put in all these steps together in a way. And again, very easy to use. Do a make VNV, do a make Jupyter, and you're good to go. So maybe this is a good time for me to hand it over to Shivdeep, who will take us through hands-on demo for how one can process their data and how one can add a new module. And then we come back to our conversation on how this community can, help collaborate and also to the point Samya was raising we'll talk about that specific point as well on syntax checking for code. Okay. With that, Shivdeep, over to you.
Yeah. Hi. Welcome everyone. I'll just try to share my screen. So, are you guys able to see my screen?
Yes.
Yeah. So, first, I'll just open this same repository. Okay. So, Hima just showed us that we have this data prep kit repository where we actually host some transforms and a library to build these transforms. So basically this library is very powerful. It gives us multiple type of abstractions to create these transforms. So one thing which Hima just mentioned is this examples. If we just go to these examples, we have one Jupyter notebook which shows the pipeline, which is similar to the diagram which Hima showed us. So the if you remember the diagram, it had some raw code, and then there were multiple stages. So we have actually put up a sample Jupyter notebook showing these steps. So now I'll just walk you through what are the things like how this pipeline works and what is raw code. So in our use case, since we are this is a code data use case. So here our input data is code data. So one of the way to get code data is GitHub or Bitbucket or something. So our first stage is usually we go to a repository, like it is not manual. We use crawlers for that, and on every repository we have this download zip. So we can download the repository using this. So for this purpose, just for demo purpose, I downloaded two repositories. I'll just show you. Just while Hima was talking, I downloaded this data prep kit, and there was one more repository I found. It was named Unitext. So I just downloaded these two zip files from GitHub. So in actual data preparation, these are like millions or thousands of these data files based on your use case. If it is pre-training use case, they can be very much in number, maybe millions. For fine tuning, they may be say hundreds or thousands. So here I'm just showing two. So here, this is in our data prep kit. We have a folder called examples. So in these examples, we have seen that we can just give command make venv and make Jupyter. It will open up a Jupyter notebook. So I had my Jupyter notebook open already. Let me. Okay. I think the window is closed. Will open it again. So I have a Jupyter notebook. Op- I'll open it again. I'll give the make Jupyter command and we'll get a Jupyter notebook running. I already did make VNV command which because it will download something. So I'll have to open it in Edge. I will open it in my browser. See, we got this Jupyter notebook up. So just now I showed that I have pre-downloaded two zip files from from GitHub like this by clicking on this download zip, and I have downloaded them into a folder called test data input. So I just need to edit this field zip input folder. So I have given the location as test data input where I just added my zip files. So this is showing an example pipeline. I'll just walk you through it. So this first one is named ingest to Parquet. This is one component which is present in this transforms. So this will convert the zip files into Parquet files, which would be in tabular format. It will have rows and columns, and each row will be having one file, content of one file. Then next stage would be exact dedupe, which is deduplication, removing the duplicate files. Then there is one more step which is called fuzzy deduplication. It actually removes the files which are similar. Then for that we need this component called doc id generation, which adds one more row which has some doc id. Then we have one programming language select where we actually choose some languages. We suppose I want to process only languages like Go, Java, and Python from all repositories. So I can use this programming language select. So it will select only the files which belong to that language. Then we have one code quality module which will actually run multiple checks uh, based on the language, uh, how much is the line length, and whether some if the if else those kind of things which are needed in the language are present. So we have some features for code quality which are already added, and we'll walk through and uh, add one more new feature in our exercise. And then there is one filtering transform. So actually in our use case, when data is very big, we don't want to lose the outputs of these steps. So we have developed these as annotators. So this exact dedupe, it doesn't remove the duplicates, it just marks the duplicates. Fuzzy dedupe also marks the rows as duplicates. Programming language select also marks the uh, rows that this has a language which needs to be selected. Then there is one component called filtering, which supports us giving SQL like queries so that we can actually filter what we want. So this one component will actually remove what all these guys mark. So this is mark, these all will mark and this will filter. And then before feeding to model, we need the data in the format which is supported by model. So model, you can think like if model is something, model eats tokens. So you need to feed tokens to model. So you have to convert your data to tokens. So this is one module which does that. So now our pipeline is ready. We have data. So what we need to do is we just need to execute all of these. So I just there is one hidden side. Okay. So I can just like run all cells, and these steps will run, and then I will have like finally process data in my output folder. So here I actually mentioned my output folder. So this is Parquet. This is one output folder where I will get Parquets from zip. So this one component is processing my zip files to Parquet. So this is running. So if I go and check here on the terminal, I'll see that I have the data in the required format. See, I have this Parquet input, which was convert. mm, mm, See what it is doing. So it is doing. This is- So this is the pipeline which actually runs and processes data. So the next thing which while this runs, I'll just want to walk you through the transforms. So we have this kit has two different components. One is library, which is the main component, which is used to build the transforms. And then there is a repository. There is a transforms folder where we actually host some transforms which are used for these pipelines. We also want that people should be able to contribute back to these folders. So like these universal transforms are one which can be used by multiple use cases like NLP use cases and code use cases like deduplication, filtering, and this noop is one very important transform, which is just a empty transform, which we use as an example to create new one. If I want to create new one, I will use noop. I'll show how to use noop. And then code has some transforms like code to Parquet, malware, program language select, and language ID has transforms which are specific to language. So we suppose I want to invent a new code quality feature and I want to contribute it. So one of the way which we just figured out yesterday was that suppose there we want to add a there is a tool called Vulture in for Python. This tool can find dead code. So if your code has some dead code which is not used, this field, this vulture can find it. And then if we create a transform around vulture, we can actually filter data and remove some dead code from it. So this is one practical use case. This transform is not yet there. We'll build it now. Okay, so what we see is that we can do pip install vulture to get vulture. And then vulture has a syntax that you give vulture by script min confidence 100, then it will report the files. Okay. So we'll go to terminal. We'll just try to create a new transform. So if we want to create a new transform, what I told is we have to go to transforms. We have an example. We just need to copy paste that example. I will just go to we can copy paste this example and start building. So now we'll copy paste this node to say CQ. Okay. Now here we have made our uh, this kit in a way that it supports Python and Ray. Now this is very interesting. we have made some simple make targets so that it is very easy for people just to put code in here. Then we have a very elaborate makefile setup which can help you scale. Like you just want to develop, you give make venv. You want to make a Docker image which you want to run on a cluster, you give make image. If you want to run this on a like if you are processing 10 files, you can use Python launcher. If you are you want to process say millions of files on a cluster, Kubernetes or array cluster, then you just have to go to a folder and it will and use this make image to build image and run that image and it will scale automatically. So this toolkit is designed so that we can actually scale from laptop to cluster, and our code remains same. So if I want to develop, I just need a virtual environment. I just do make venv. I got an environment. Then we have a command that like if I want to run a sample, make CLI sample is there. It will run my sample. So I have one sample running, which already runs and which uses the test data. What I will do now is first I will replace the test data with my repositories, okay, so that I can use so we'll put test data afterwards. I'll just show you how to what to add and how to add. Now I had for my demo I actually created one folder where I have added something related to vulture. So here, if I show you this vulture, which I just showed you, if I want to use this vulture, I just wrote this code to use this vulture in Python. So I made one function called find that code, which takes a file and runs the vulture command, and then it can give me true or false. So example is like if I give this code, this doesn't have a dead code, but if I have this code, it has some variables which are parameters of a function, but they are not being used. So this code is not being used in this function, so this is dead code. So this function can figure out that code is dead or not. So first we need is we from vulture we can have our own function which actually uses this to detect whether that file has dead code or not. So this we did. We just created a function called find dead code. Now thing is this is just a function. If I want to apply it on a data frame or in pandas, so I will just use pandas. So one way to use is that I read a file into pandas and then I can create, I can apply this function, find that code on a row called title and contents. Title will just have the file name and the contents will have the contents of the file. So I will use this code to develop a filter. Okay. So here I have this. I have with I will just add one party here. I think. I okay. So here now we'll see how to create a transform. I just showed you a function which we have created for vulture. Now we want to put it to what the- now we will try to put it into our transform. Now I'll just show you our abstractions what we have. Okay. So now we in our code when we write a transform we have some these files. One is transform.py. This is the most important file where we actually have to put our code. So rest of the files can remain as it is. If we are writing simple transform, we'll just go to this transform file. So if we see there, we'll find some classes. One class is new, this abstract table transform. This is the transform class. So when we say transform, it is just a class which can convert one table to another. So in our use case, what we want is we want to take the input table and we want to convert it to some output table, and we want to remove mark the dead code. So if we see this has this function called transform. This is the main function which does. So if I want to create a transform, I just have to write this class. So we have one init here, and we have one transform here. This is from where we should start. So I'll just walk you through this. So if I'm writing a transform and I am a transform developer, I just need to add my code to this function. So here, if I see the signature, it gets a table, it outputs a list of tables. So it means that I can even split tables. So here, suppose I am here, what I can do is I can import my file. So what I named it deadcode.py. Okay. So we can just like import deadcode from that or from deadcode import as deadcode. Okay. This is the function which we want to use. So now when what I showed you here is that if I want to use this function, find that code with some data frame. So this is the way I can use it. I can convert the table. I can, if I have a pandas data frame, so I need these 3 lines, 4 lines to convert to actually add a new column called head has that code, which adds a new column using this function. So I will actually paste these here. Okay. So
So Shivdeep here,
yeah, yeah.
in your transform function, you're passing the table, right? Is it the
It
Parquet
is a
file?
pi arrow table. It is a pi arrow table passed from a Parquet file. So
Okay.
there is a feature. We have a feature which is like
Mhm.
you can read a Parquet file or you can read any file.
Okay. Do you mind showing the Parquet file once that which you have generated? I could see that you have some unit text dot
Yes,
Parquet.
yes, yes, yeah,
Yeah, I just want to see like how it looks like.
yeah. Uh, I- yeah, I'll just show you. Okay. I actually placed it somewhere, which let me see the name. We, its name is unit exp. Okay. I have to create it. Okay. I will just show you. All other Parquet files are similar. We actually will create it. Currently, I'm just writing it. I'll show you the how Parquet files look like and where it is kept. It is kept in test data input. Okay. Here we have test1.parquet. If you want to see how it looks like, is it has columns which are like uh, it has a one column only title, like this file which I kept here in the sample code. It has one column for
Only
title. Okay.
title.
Yeah. If this would be read into pandas data frame, which has two. Okay.
So how
So
about the content?
okay, I'll show you. So currently, this needs a content also. So
Yes.
we will use the pipeline which I showed you here. This
Mhm.
one, this portion will convert the zip file. This ingest to Parquet. We have one component called ingest to Parquet. This converts the zip files into Parquet files. So this can convert my Parquet file unitext to unitext dot Parquet. So this is the one component which can convert and which will convert. We'll use this to convert. Okay. Just
So maybe Shivdeep, you can show the output of that particular function where
yeah.
two files were generated, and just we can see what that Parquet schema looks like.
Yes. I just let me see. I'll run it. Let me check it. Yes, yes, yes. Actually, in this activity, we'll actually create it. So that is one way
Mhm.
that we will actually create this very.
No, no, I think you're not on Bash. So
No, wait. Look, actually, I think some problem happened to this.
No worries, Shivdeep. Like no worries. Like we
Yeah,
can
I'll,
meet at the end of the session
I,
also. Thank you.
I actually lost my unit text.
No worries.
I'll find it here and I'll show that there is a file. We'll have to keep it here. It will have two columns. Okay. So now if I want to go here, so I was showing you that what we want to do is we want to add some code which processes this transform, this table and returns a table. And that is enough for us to implement a transform. Rest of all these commands are there, like make CLI sample to run. So we need some data to run and we just need some code which we can just wrap. So here we will wrap our this uh, get code.py will wrap these files, these lines, and it becomes a transform for us. And we can keep other file which has that columns and it will also run. So if we see this, so we can So this way, I have created a data frame. Like I convert a table to data frame. Then I just ran my function has that code on two columns called title and contents, and then it should label it, and then I added a new column has that code, and I got a new data frame. Now I can just convert this data frame to table. Say out table, and my transform is ready. So next create dot table dot from pandas. So so now my transform is ready. So this can be used. One thing is I just need to move the file to that location also. Let me copy this file. So I will show you. Now my transform is ready in this Python folder. If I put it in, if I use it from Ray folder, then it scales better. So now I'll just copy my file that code here. Okay. Now I have my transform ready. Now my requirements is that if I do make VNV, it already creates a virtual environment. So it's very easy to use it. So I can directly run make CLI, make that CLI sample, it can run. I'll just take one output from one Parquet from code data. Code data already has Parquet, which has this code quality. If I go to code, code quality with Python has data. So it already has some data. It has some data. Universal. And our folder was Shivdeep. We'll put some data for our testing so that we can just show the demo. Now we have three files. We'll remove first one because it doesn't have our column. We'll just check the columns. Hima, we have contents and language. Okay, it doesn't have column title. So one thing is, if I want to just run it, I just need to do this make CLI sample. But before that, since my transform has an extra dependency, so I should add my dependency. I should activate my virtual environment and add the vulture activity. Yeah, vulture, sorry, dependency. So I need to install vulture. Now my transform would is ready to run. Like now this transform can run if it gets some file which has that two columns. Find how I lost the CD data for we will remove this one, only one, and we'll try to use our transform to generate it. Before demo, I did it. I got it. Let me check. This happen. Total files versus I think zip file may not be correct. So this try to find. I'm not able to find my file. I don't know why it's misbehaving. Otherwise, I should have got my passkey to show the dump. Just try to search if it is already there. I can. Okay. So here, this is the one like I have to do run CLI sample to actually run this on data. So currently it doesn't have that field. Oh, sorry, I forgot it. Maybe I have some syntax error here. So this is the way actually we add a simple transform. So I'll actually show some other feature also. So this is the easy way. So you just have to add something to this folder. It becomes a transform. Now there is one additional thing. Sometimes you need some more things which you want to add to this transforms. So we have this constructor which takes a dictionary. There you can actually pass extra parameters which you want to use in the transform. Like here we have a sample called sleep check. Otherwise, this is just a demo, just to show that you can pass any parameters in a dictionary called config. So you can pass parameters to your transform and use them here. Now, the interesting catch here is this config is actually passed from something called configuration. So we have actually two more components which help this transform. One is called runtime and one is called configuration. So they are important concepts. So configuration actually converts your transform into a command line application. So you can actually add some parameters like minus minus sleep, minus minus language equal to something. So all kind of flags which you want in your transform can be added by updating them in something called transform configuration. So you just need to add one more parser R here in this function in the transform configuration. Then we have one function called apply config input params where we actually validate this. So we can add the component, add it new command line parameter here. We can validate in this apply functions, and then it would we can add it to a dictionary called params. Then it would be automatically received by the transform constructor. So this has one more interesting implication that we have something called runtime also. It is not used in Python. So it is used in Ray. We have two types of launchers. We have a terminology called launcher. Launcher will actually convert this configuration into a command line application. So we can convert it into a simple Python application, and this is the first option, which is not usually scalable. It is only for testing. Other is Ray launcher, which converts that into Python, which uses a component called Ray, which is used for developing distributed systems. So we actually keep it in separate folder. So we keep our code in Python folder, but still there is one array folder where array runtime is kept. So if I do make run CLI sample from here, it will use the Ray launcher to run my transform. Ray launcher is the scalable thing which can run on your laptop, and it can also run on the Kubernetes cluster, or it can also run on any kind of SLURM cluster, any cluster which just hosts Ray. So first uh, dependency is Ray. If Ray cluster is available on AWS or anywhere, so this transform can directly run on Ray. So there is one more thing which I didn't add earlier. I'll just show you that we have a abstraction called data access. So data access is our abstraction to read from multiple sources. So our data access can read from S3 or local. So you can keep your data in your local folder, or you can even keep your data in the cloud. So we have something called data fact. I'll show you data access. So this is one data factory. This is a abstraction offered by our data prep kit. So this factory automatically detects whether your is source data is present on your local computer, or your source data is present on cloud. So you can keep your data on AWS S3 bucket or on IBM COS. So S3 is just a protocol. It can be kept on any cloud which supports S3. And then uh, in our transform, if we use this data access factory to read the file, then this is the way we create a data access from factory. Then we can just read the files. Like here we have a function which will read the file. I'll just show you this one. This get supported takes a data access. We can use data access to read data. So we if we use this data access to read data, we don't need to know where the data is. It will automatically detect whether your data is on local or on S3. I'll just show you one.
Hey, Shivdeep, maybe time check. Would you need some more time?
No. I think I'm up. I just want to show one S3 related file if it is there. Just, yeah. So we I earlier I just this is the file which are automatically kept. These are like samples which we have kept so that you can directly run this toolkit. So this sample actually uses S3. So you can actually keep your access key and secret key of cloud S3 bucket and give the location of your S3 bucket and run this application, and then it will run your transform on the data, and it will pull the data from S3 and write it to S3. So this data prep kit gives us one important feature, that your data can be on local or S3. Other feature is that it can run locally or it can run in a scale mode. So from your side, you just have to write your transform in the way I just showed in the src folder in the transform file, and you just have to give the uh, wrap the implementation in the transform folder. So there, that is the simple way of in adding transform. There are some complex transforms also. We have tutorials in our documentation, so you can go to our documentation and see the tutorials also. So we have some good tutorials. Just if I can show you. So this is so in the data prep kit in the docs, you can so here in the docs you can actually have the see the tutorial if you want to develop some advanced transform. So we have example for that EDTube. The one which I showed is the simple transform. So I think if Hima you want to take over, you can take over. I
Okay.
I was like I just lost my parquet which I created
No,
before that.
no,
But
don't
I
worry
have
about it.
shown
Don't
the
worry about it. I
actual
actually have it on my system, Shivdeep. I can quickly show. So if it's okay, can I take over?
yeah, yeah, you can take it.
Okay. Mhm.
Yes.
Okay. Thanks, Shivdeep. Okay, just to wrap up this part of it before we move to the next part, can someone confirm if you can see the Google Chrome, you can see the demo notebook?
Yeah, yeah.
Yeah.
Okay, thanks. So this is what Shivdeep was showing, right? What I just did was exactly the same thing. Basically, I think he was showing, I downloaded right the zip file from here. Okay, and I just ran the ingest to parquet function. Okay, and I think someone had a question what the Parquet files. So what? Okay, so the starting folder or the starting for this was the .zip file. When I ran the ingest to Parquet, it got converted into Parquet, and someone wanted to, I think, understand what the schema looks like. So this is what the schema of the Parquet file looks like. It gets the same name. So my zip file was called DataPrepKit dev.zip. It became DataPrepKit dev.parquet. And as you can see, it will have a title column, which is basically the name of the repo. The most important part is the contents column, which basically is going to have the whole code file, right? So corresponding to the file name that you see here, the contents of the code file come in the contents column,
Yeah.
right? And then
There is where I have a question. Sorry for the interruption.
yeah.
Suppose in our corpus, like we might have a Python file or HTML. Maybe based on the title, you can filter the
Hmm.
language that you want to work on. If you see, like I'm kind of working on a use case where, like, I have Python inside my Python file. I
Hmm.
have HTML also, JavaScript also.
Hmm.
So did you face this scenario, and then did you try handling, and if yes, like how did you handle that?
Oh, so I think what we do is in the Parquet file, if there's an extension column, which will say, okay, what type of file that is, right?
Yeah.
Largely based on the extension, right? We've not, I think, had to face too many issues where we had, okay, a Python file, and within that we had nested languages. So no, not so much, Valaguru.
Okay. Okay.
But that could be, I think, if that's a use case. I mean, we've just not seen that as a need in all the work that we have done. But
Mm-hmm.
if that you think, right, then that could be a contribution that you could
Yeah.
make, to the toolkit.
Sure. And coming to this one, like PII, where you were discussing about removing all those personal identification.
Mm,
Um, uh, what so I worked on this use case where I was trying to translate Oracle to Postgre queries. So I had to mask all those variable names. Like if we have a chart from employee table, like I was like trying to mask that.
mm.
So in your case, like, are you just removing it, or else you are trying to mask it?
How we mask it. So for our internal work, we I think detect 6 to 7 entities, and let's say if we are detecting a name, then we mask it by the keyword name within the angular brackets.
Okay. Okay, so the masking strategy will be same for or irrespective of the programming language.
Yes, irrespective of the programming language. That
Okay,
way, I think you're not showing too many new tokens to the model.
okay, sure. Are you okay taking one more question, or like should I wait till?
Good, good.
Yeah, I'm just curious to know about the tokenizer. What you use? Like, did you use any pre-trained tokenizer, or you came up with your own tokenizer for this use case?
No, we didn't come up with our own tokenizer. We basically use the Starcoder's tokenizer. So Starcoder is another, I think, open source model, and
Mhm.
have a pretty neat tokenizer. So we tried, I think, with a few tokenizers that seemed to work best for us.
Okay, okay, sure. Thank you, thank you, thank you. Thanks
No,
for
no problem. Thank you. Thank you for your questions. So I think, yeah, so you can try this out on your own. This should just work. The other thing, right, just to I think wrap up with what Shivdeep was saying. So let's say to add a new transform, you can like go to no op. No op is nothing, no operation. It's just an example dummy transform. And like Shivdeep was saying, let's say if you have your logic ready, right, in a Python file, like let's say Shivdeep was giving an example of okay removing dead code, but wherever like if you have your logic ready in a Python file, you have tested it, it compiles, everything is good, then to add it as an operator, right, you basically need to I think just look at two files, right? One is no up underscore transform. So if you copy and you let's say you make this let's say you're making a transform for dead code, right? Then you will copy this folder and then it will become dead code underscore transform. Within that, right, the only thing that you want to care about is that there is a transform function that you can see here. You just add your Python logic here, right? Just call to your function that given a row of the pyro table. So a row of the pyro table will have, like I was showing you here, right? It will have this kind of things. It will have the content column. Content column is where you want it to work on. So, it takes in a row, calls your function, does the logic, gives then back an updated row or whatever. And then I think the rest of the things the architecture will take care, right? So that's the change that you need to make. That's where you add your logic. Of course you will need to change the class names and so on. And then if you want to run it on the, let's say, the Python runtime, then again you come back, change your class names here, it will run on the Python runtime. If you want to run it on the Ray runtime, you can go back, go to Ray, right, and add the relevant class names here, and you will be able to run it on the Ray runtime with all the other goodness that Shivdeep was talking around, right? That it can detect whether your data is in the cloud, it's on local, so all of that. So you can basically use this toolkit to run it on your local system. You can run it on cloud. You can run it on your cluster. So that's I think the other advantage, that the toolkit allows you to scale from local to cloud pretty seamlessly actually. You'll of course need like some configuration changes, but that's not too much. Okay. um I think in the last segment, what I want to do is I think I want to talk about, how the group here and generally I think the community can contribute, right? So you could start. You could right, if this is interest you, this is an area that you're working on, and you want to work in the open source space, right? You can start as a contributor to transforms. You can then grow as a peer reviewer, and then you can have right you can really I think grow and become I think part of the core team and so on. So that's the general journey. That's true for I think most open source projects. For our case, right, for you to get started, right, would be to say, hey, uh, one could I think go to the open issues, label and look for good first issue. These are all examples, right, where which we know are open needs, and we're hoping that the community can come and contribute. This was also, I think, to the question that someone was asking earlier, right? So, We want to, I think these are all open issues at this point of time to say, hey, we want to verify if a C program is compilable or not. And then, you need to do this across languages. Or someone could come and say, hey, I found a way. It's pretty generic. I can do that across 10 programming languages. So that's also fine. I think some other issues where someone can start contributing easily could be, let's say if you have NLP data, you want to also check for, okay, other grammar, punctuation, spelling errors. These are, um, you'd be surprised of how much we find these actually in the text, right? So that could be something, or beyond, I think what we've done on hate, abuse, profanity, there could be other toxic words that you may want to filter out from your code or NLP, or what we were just discussing, that hey, I want to, if I have a JavaScript code, I want to, write a function that can make sure that that just checks whether the code is going to compile or not. This is, in my opinion, this I think is super important, because you don't want to share code or put code into the LLM which has this basic problems, right? And the way for someone to start contributing would be to, I think, pick up an issue that you think is interesting, and basically, I think, just raise a PR when you are ready, or use the same issue as communication, and you can ask for help and say, hey, I'm trying to do this, and maybe here's where I'm getting stuck. So I think those are kind of things that our team can help you with, right? Okay, I think I can stop here and we just keep the last 5 minutes to see if there are any other questions, um, any other discussions, or anyone has anything else that we think we should cover. Yes, Samya.
Hey, hi, Hima. I just want to confirm one thing. Is there any separate Slack or some Discord channel for collaborating with the community, or it's directly with the GitHub comments and then that can be addressed?
Yeah, I think right now we want to stick to just the GitHub comments. We don't have a Slack or Discord, but we may, I think, decide to change that. But at this point of time, I think our opinion is that let everything be in one place and we don't fragment the community, and let everything be on GitHub.
Okay, okay. Yeah, thank you.
Welcome. Any other questions? Any other suggestions of how how uh, or challenges that you have faced while doing some of the work that you have been doing? Okay, if there's nothing, then I would like to once again, on behalf of myself and Shivdeep, thank the organizers for inviting us, and thank everyone to come and listen to this discussion on Saturday morning. I can imagine that it really needs, I think, passion and a lot of conviction, right? And really, I think, to be techies to, I think, do this on a Saturday morning, attend a webinar. Everyone has lots of other things to do. So really appreciate everyone coming in, spending time, and thank you for all the discussions.
Yeah, thank you, Hima and Shivdeep. Maybe one suggestion from our end is probably we can do some kind of sprint where people can actually come and contribute from our end, like from AI Tamil Nadu communities end. We may try to run such sprints maybe in the future.
Yeah.
And that way, we'll get more participation and you'll also get more contribution, right? So I think we'll plan something out and I guess we'll collaborate on that.
Okay, I think sounds good. Thank you so much, Abhinav.
Yeah. And I would just take 5 minutes of your time to talk about one more initiative that AI Tamil Nadu as a community has started. I'll just share my screen and talk about it. So, in the recent times, in almost all the events, people have been asking about. I hope my the image is visible, right?
Yes.
Yeah. So I think most of you might know the AI Tamil Nadu community. You have been attending events in person, but for those who are joining for the first time, we are a non-profit community run by a lot of volunteers, and we have been doing this for the past 6 years, and we have been conducting events, educating people about AI and a lot of emerging technologies. In the recent times, we have had requests from both industry as well as like professionals and students to start an initiative where they could apply for jobs, and we can actually match the like whatever the industry has as profiles. Probably we would like to help match the student and professional profiles to those jobs. So we just started this AI Tamil Nadu job matching initiative. We'll soon update it on the website, but as of now, you can make note of these two links or scan the QR code. If you are someone looking for opportunities, you can apply using the job seekers link. And for employers, if you have openings and you want people, we would love to. As a community, we can volunteer in doing interviews or doing the first list of shortlisting, and then probably we will send you good resumes. This is like a complete voluntary effort. There is no money involved, nothing. We are just doing this because we have been seeing that gap somewhere, especially in tier 2 cities and all that. So we wanted to do something from our end. So this is the new initiative that we have started. So please spread the word about this. We'll also update this in our website soon, so that you can directly come to our website, and all this information will be there. So I just wanted to share this. And yeah, thank you so much again for joining on a Saturday. I know it takes a special place, first of all, to come and sit in a 2-hour session. And I see that a lot of you have stayed till the end. Thank you so much for that. And we hope to host more such events, especially in open source, because a lot of students and professionals have been reaching out to us and asking us, like, how can we start contributing open source. So I think we will continue this series, and we may keep bringing people like Hima and Shivdeep in the future as well. Maybe if needed, we can do more sessions on data prep kit also, if there is more interest in contributing to the same. Yeah, that's all we have for today. Again, thank you for joining. We may send out this information for all those who have registered. We'll send you the link to this portal.